So now we want to find the quotient of this. So first thing we want to do is rewrite it. So we want to rewrite it using our rational exponents. So we would have y to the 3/9 over y to the 9/3. Now if you can simplify your exponents, you want to do that. So this becomes y to the 1/3 on the top, and on the bottom we have y to the 3rd. Now since our exponents are the same, we can subtract, or since our bases are the same, we can subtract our exponents. So 1/3 minus 3. So since 3 is a whole number, it's like 3 over 1, and we still need common denominators. So this is going to become y to the 1/3 minus 9/3. And we get y to the negative 8/3. We can't just leave that since we have a negative exponent. So we're going to rewrite it first as 1 over y to the positive 8/3. And then we're going to change it into radical form. So the 3 is on the outside, y to the 8th is on the inside. Now we can break y to the 8th down a little bit. 8 you can't divide by 3. So we can rewrite this here, the cube root of y to the 8th can be rewritten as the cube root of y to the 6th and the cube root of y squared, which would then become y squared on the outside, since 6 divided by 3 is 2, and then you have the cube root of y squared on the inside. So what we really have is 1 over y squared cubed root of y squared. And we're still not done since we have a radical in the denominator. So we need to rationalize this. Since I have the cube root of y squared, I need to multiply over the cube root of y, so that way my exponents will be a 3 and I can divide that. So now I have the cube root of y on the top. On the bottom, these two together are going to be the cube root of y cubed, which equals y. And I already have y squared, so now I have y cubed. And that would be my answer. Now for this problem, we have to first see if we can do anything with it. So first convert it to exponential form. So we have 18 to the 1/4 times 12 to the 1/2. So we don't have the same base, so we can't add our exponents. And we don't have the same exponents, so we can't multiply our bases. So we just want to see if we can break anything down. So the 4th root of 18, if we try to break 18 down, there's not going to be 4 of the same. So we're going to leave that as the 4th root of 18. But we can break down the square root of 12. Square root of 12 is 2 radical 3. Okay, and we're just going to leave that as our answer. Now in this one, when we go to rewrite it, 7 to the 1/7 times 7 to the 1/3, because my bases are the same, I can add. So I'm really going to have 7 to the 7 plus 1/3. And we need common denominators, so I can make this 3 over 21 plus 7 over 21. So we get 7 to the 10 over 21. So we can leave it like this, or we can rewrite it as that. And I wouldn't make you guys do 7 to the 10th and have an actual number in there. You can just leave it as 7 to the 10th. Now for this one, when we go to write this, okay, so let's rewrite at the top. We're going to have x to the 4th, y to the 1/2. And on the bottom, we're going to have x squared y to the 8th to the 1/4. Now, we kind of have a problem here because we're not going to be able to multiply these together to rationalize the denominator because we have different indexes. So the index on the top was a 2, the index on the bottom is a 4. So what we can do is we can make them have the same index. So if I wanted to make them both be 1/2, I'm going to keep the top exactly the same. So x to the 4th y to the 1/2. Now, the one on the bottom, if I want to change this index to a 2, I would divide it by 2, because 4 divided by 2 is 2. That means each exponent I have to also divide by 2. So I'm going to rewrite this as x y to the 4th to the 1/2. So if you see, these two, they're exactly the same. Even though they're written differently, if we were to apply the exponent, if we took the initial one and did 2 times 1/4, that would give us half. Here, we really have 1 here, times 1/2 is 1/2. 8 times 1/4 would be 2. 4 times 1/2 would be 2. So they still end up simplifying to be the same thing. So we can rewrite them differently. So I'll leave that there. I'm just going to rewrite this over here. So we had x to the 4th, y to the 1/2 over xy to the 4th to the 1/2. So now we can actually simplify this up. So we're going to have the square root of x to the 4th y over the square root of x y to the 4th. So we could write this now either as a giant radical, because they're the same exact index now. So x to the 4th y over xy to the 4th. When we go to simplify this, we're going to get x to the 3rd and y to the negative 3. So when we have a negative exponent, we want to make sure that we bring it to the bottom. So we're going to keep this as the square root of x cubed. And on the bottom, we're going to have the square root of y cubed. So we can simplify a little bit. So the square root of x cubed is going to be x raised to x. The square root of y to the 3rd is going to be y radical y. So now it's rationalize. So multiply by y, the square root of y over the square root of y. So this is going to give us x radical xy over, these two are going to become a y, and I already have a y, so now I have a y squared. And that's going to be my final answer. Okay, so what's each number in simplest form? So we can figure out what these numbers are without even using a calculator. So 32 to the negative 3/5. Well, think about it. The exponent's a negative. So we have to rewrite this as 1 over 32 to the positive 3/5. So now we have 1 over, and let's rewrite this now as a radical. So my exponents are 3 and my index is 5. Now 32 to the 3rd is kind of hard to do without a calculator. So let's always work outside in. Okay, if you do 32 to the 3rd and then take the 5th root, you can do that, but you'll probably need a calculator. Now the 5th root of 32, 5th root of 32 is 2. And now we're going to raise that to the 3rd. So we end up with 1/8. So 16 to the 3/4. So we're going to rewrite that. 16 cubed and take the 4th root. So the 4th root of 16 is 2, and then 2 cubed is going to give us 8. So you could do, again, 16 to the 3rd, and then take the 4th root. And then for the last one, we want to make sure again that we change any decimals to fractions. So we'll have 9 to the negative 7/2. So again, we can't have a negative exponent, so 1 on the top, and then we're going to have 9 to the positive 7/2. So let's rewrite this as 9 to the 7th, and then squares, this square root. So again, outside in, the square root of 9 is 3. Right, and then 3 to the 7th is going to give us 2,180. So now that we're simplifying each of the numbers, we have 64 to the 2/3 times 64 to the 2/3. So because the bases are the same, we're going to add the exponents. we're going to rewrite that as 4 to the 3 halves. And then we have the square root of 4 cubed. So again, outset first, square root of 4 is 2. 2 cubed is going to give us 8. Negative 32 to the 6 fifths. We're going to have negative 32 on the inside. And then 6 is our exponent, 5 is our index. We're going to put outside in. So the fifth root of negative 32, that's negative 2. And then we're raising that whole thing to the 6th power. So that's going to become 64. And then the last one, again, you want to change the 0.75 to 3/4. So we have the fourth root of 10,000 cubed. So we'll take the fourth root